Good morning. Here we are live coding again. The topic for today is Studio, which is a open source project, a very new one that I'm working on. And we're going to pick up where we left off yesterday. And our big goal for today is to get Studio ready for Snabb hackers. So this is something now we spent a lot of time developing, and it's time now to actually share it with the initial target users. So what we need to do is just go through and clean house a little bit, see what are the things people are going to trip over on right at the beginning, and try to sort those out. Just to get people out of the gate smoothly. So I made a little to-do list. First thing I want to do is just very, very briefly recap in a couple of minutes what is Studio and what have we just done on tidying it up yesterday. Then Max, famous Snabb hacker, has taken it for a spin and hit an installation error. He actually reported a long time ago, and I kind of lost track of. We're gonna look into this and see if we can fix this in a good way. And then once we've done that, we're gonna look at pulling in data from the Snabb continuous integration server, so that if we see something funny on CI, we want to understand how things work, we can pull in the data and examine it with Studio, and we'll focus on profiling here. So it's a major use case for Studio is when some process runs in a funny way, for instance too slowly or something like that, either on CI or any other environment, to be able to pull the data in and take a good poke around and see what's going on. So away we go. First, very briefly, this is Studio, right? It is a graphical tool that is like a Postmortem debugger of sorts for applications. So this is what we're seeing here on the left is profiler data from a RaptorJIT virtual machine. And we can click around and explore the profiler data, and we can also click around in more detail to the code being profiled. So here we have a visualization of the kind of machine code that was generated by the JIT compiler for a certain function. So that's what Studio is. It's kind of like a very, very fancy graphical version of GDB that deals with a lot of different messy data sources. So yesterday we made this a bit easier to install, and I kind of polished up what we were doing there and posted it. So if you go to the Studio's GitHub page, you would now see a little cheat sheet for installing Studio. So if you want to, if you want to also try mucking around with the same demos that I've been doing, first you get Nix. That's a one-liner to do it. You can also probably use apt-get or yum or whatever, because Nix is widely packaged. Then you've got to get the Studio sources somehow, for example with a git clone. If you want to, you can switch to a particular branch or commit or whatever. It's just going to run whatever you have in your source tree. And then, this is what we did yesterday, we made this little bin Studio script that just runs the GUI directly out of the source tree. So now there's not any separate kind of build and installation step. You just tell it to run, and the build all kind of happens transparently behind the scenes and is up to date for whatever version you have in your source directory. And you can run it either as an X11 client if you have an X server handy. If you don't have an X server handy, you can run it as a VNC endpoint, and then you can connect to that from somewhere else. Fine, that's all very nice, but I gave these instructions to somebody yesterday, and it didn't work. And the bug, I have a nice bug report, and it's interesting because this is an example of exactly the kind of problem I don't want to have. So I'm hoping to fix this not just in this instance, but to come up now with some kind of a once and for all kind of a fix. Let's find the issue. I think it was 48 or something. Yeah. Okay, the thing that happens is we try to install this nice fancy Pharo Smalltalk GUI, and at a certain point you press the play button to run your program and you get an error, and the error seems to be that the wrong shared library version has been used. Now I'm using Nix to install Studio, so in principle you should get all of the exact shared libraries that I want you to have should be bundled in with this. So we're not supposed to ever have this situation where you run the application with a different version of a shared library than what I have, because it's all kind of like, in the style of Docker. It's more like a unified distribution of all the libraries. So how did this happen? I think probably what happened here, something that I've seen happen before, is that some applications, such as Pharo Smalltalk, have some hard-coded paths in them. They go looking around on the file system, trying to kind of guess where a certain library might be found. So in this case, I think probably the Nix code that I've written has probably taken this library and I would imagine put it into the LD library path, unless this is something I've missed in packaging, which is also something we should pick up. But probably we have the right version in the LD library path, but possibly it has said, hey, you know what? I bet I can just find this in user local or in user lib or something like that. And that's not cool, right? That's a pain in the ass. That's some hard coding that maybe works on Ubuntu and maybe works on Fedora and just pisses everybody else off. But that's reality, right? So everyone's kind of does things in their own style. So we need to compensate for this somehow. And what I want to do first is think about using Nix to actually sandbox this whole process so that it can't see any of those paths. So what I was thinking is we could run the GUI in a chroot such that it can only see the software that we want it to see, so that if it goes looking for /user, there will not be any /user because we don't want there, from the perspective of this application, we don't want that folder to exist and be visible. So let's just have a look at whether we can update the script that we wrote yesterday for running the application to, if we can update pardon the kids in the next room. Anyway, if we can update that script to sandbox the application, let's have a look. We'll hop over to our little script. Where are we? We're here. This was our script. We're running Nix shell. We're giving it a few options. I revised a little bit since the stream yesterday. For instance, I made it run a lot of parallelism for when it does downloads, because that speeds up installation. So it runs Nix shell. It tells it to start a shell, like a bash shell, with a software environment defined by this Nix expression, which basically means download and build all of the software that's needed for the Studio application and make it available in this subshell, and then in that shell run the command Studio VNC or Studio X11. So what I think is that we can find an argument on Nix shell to maybe provide a little bit more isolation here, so that we can run, when we do create this subshell, maybe we can, for example, put that in a chroot where it won't be able to see anything that we don't want it to see, which would be kind of neat. So let's pull up the man page for Nix shell, shall we? So pure sounds promising, otherwise there might be some kind of common Nix options we could look at. So what does pure do? If this flag is specified, the environment is almost entirely cleared from before the interactive shell is started, so you get an environment that more closely corresponds with the real Nix build. A few variables, in particular home user display, are retained. That doesn't say anything about like a chroot or anything like that. So let's just see what we, so do we have a /user at all here? I'm running this on Nixos. Oops. Okay, so we have a few things in /user, almost nothing. We have user bin env and we have user local bin snab. Those are the only things we have in that tree. So on this machine, if you go fishing around for shared libraries in /user, you don't find anything, and that's why I haven't seen this problem that was reported, because I'm running on a machine that doesn't have any funny arbitrary library versions in places that applications might go looking for them. So if my Fedora Smalltalk GUI is looking in /user for libcairo or something, it's not going to find anything, and there'll be no harm done. So, but let's just see if we can hide this somehow. I would like to I'd like to make this invisible somehow to the GUI when it's running. Let's just try a couple of things for that. If we go back, so we have this Nix shell. If we take away this ---- run, then what we're going to get is an interactive shell. And then we could just poke around. So let's do that. Let's run a similar command, Nix shell -e. We'll take import. What would happen if we would say that? It should give us a bash shell. It'll get all the software dependencies ready. Okay, and now we're in a bash shell. It should have that software. Yeah, okay, so now, do we have /user here? Yes, we have /user. Okay, what about if we repeat that, but now we give this the pure argument? What is this? So the question now is this going to hide /user, or is it only cleaning up our environment? It's not hiding /user, okay. Let's see if there's a nix option we can use. So there's a nix.conf, which has a lot of kind of common options, and I think there might be something here that we can pass in. And I'm not sure actually if the idea with nix shell is ever to run in a chroot. I mean, chroots are something that Nix often uses for building things, whereas the nix shell is more something for running things. So I'm not sure if we're going to find what we're looking for, but there's only one way to find out. So let's search even for chroot. Build use sandbox. We might even do a Google search to see if you can get nix shell. Chroot sandbox. Is this something that you can do? Can I use a sandbox with nix shell? Hope I didn't write this question. That would be embarrassing. No, nice. Is there any way I can use build use sandbox option with nix shell? I'd like to get an interactive shell in the same super clean environment that the nix build is started with. Okay, it seems like we have the same issue. Doman, who is a super nix guru, says there's a duplicate of this. Okay, yes. From a year and a half ago. Come on, blah, 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 blah. What is this? I don't really feel like I found the answer there anywhere. Go back to Google for a moment, see if we can get any new entry point there. I mean, I guess the alternative, which is a bit of a pain, is we could do the chroots ourselves. Oof, how do we want to do this? This would be a wonderful time for somebody on the live chat to leave a comment saying if we can get nix shell to run in a chroot. I'm tempted to put this down and maybe come back to it, do it, because I think what we need here is a little bit more Googling and maybe open an issue on, maybe look more closely at those issues on GitHub and see what kind of conclusion was there. Is there anything new that came up, that kind of thing. I'm gonna come back to this because it's not something I want to do right now. I'd rather do something a little bit more meaty right now. I'm not in the mood for kind of Googling through GitHub threads any more than we already have. So what we're going to do is we've already recapped that. We've looked at that as much as we're going to right this moment. So now we're going to just have some fun. We're going to look at importing data from the Snabb continuous integration server into Studio so that when something funny happens, we can poke it with the Studio GUI, which is big, right? So I spent a lot of time building this graphical application. This is the absolute main use case that I've had in mind. And now we're going to actually get this working and in such a way that we can very easily share it with other people who need this and want this. So this is kind of exciting. So we have just to talk about so here we got Studio examining a RaptorJIT process, but this is not particularly a Snabb process. This is something where we got RaptorJIT to download a tarball containing some benchmarks and run that. But what we want to be able to do here is to say something like snabb.inspect, then give a URL, or a directory, I suppose, as well, but we'll start with the URL, where we've got a tarball containing the state of a Snabb process, for example, from continuous integration, but also from somewhere else. So before we dive into that, let's just look very briefly at what is this state that I'm talking about. What does a Snabb process look like? So we hop to another shell on a machine that runs Snabb. Incidentally, Snabb is a user-space network stack. So it's an application, you can think of it a little bit like Nginx, but instead of doing HTTP, it's doing raw Ethernet packets, more or less. High-speed networking application. So on any machine that runs Snabb, you'll have a folder called var run snabb. This is a RAM disk folder where application state is stored. We don't have any Snabb processes running on this machine right now, so all we see is this kind of a mount point that we have to help us allocate and share DMA memory. But if we start a Snabb process, then it will get more interesting. So yeah, so this is how to run just a synthetic benchmark with the parameter that will run for a little while. So now we have a Snabb process running. So if we look in that folder again, we have a subdirectory for a Snabb process with the PID there. So now we can look in there, and we've got some interesting stuff. We have a file called audit.log. This is generated by the RaptorJIT VM, and it contains all of the generated code and all of the attempts to generate code, and a lot of the information that we're then going to visualize. So hopping back to the GUI for a moment, this comes out of the audit log, this code snapshot, and a lot of related information comes out of the audit log. So that's great data to have. We also have this VM profile folder. This contains profiler datasets. So for each component in the system, we have a profiler dataset, which is a big-ish file. So the profiler data is basically a matrix where it has a row for each different bit of kind of machine code in the system, and then the columns are what was that bit of code doing? Was it executing a loop? Was it running the garbage collector? Was it running foreign code? Was it running the interpreter? This kind of thing. So it's a big matrix of profiler data. And then we also have other things like counters. We have counters, some counters that are simple, that's just 8 bytes, that's just a 64-bit counter. We also have a little bit more complex ones like the latency histogram. This has kind of logarithmically scaled buckets that precisely counts how for each and every iteration of the event loop, it has a precisely bumps a bucket with the number of kind of microseconds or nanoseconds that iteration of the event loop took. So that then you can see very precisely if there was ever any single cycle of the event loop that was unusually long, for example, you'll be able to see that there, and you can get statistics. There's a lot of cool information here, and one thing to know about this is that these files are on RAM disk, and they're also being updated mostly not with like write system calls, but rather as file-backed shared memory. So when Snabb wants to update a counter, or when it wants to bump profiler data or anything like that, it doesn't initiate any file system access. I mean, this is on a RAM disk, so file system access would be reasonably quick, but it doesn't do that anyway. It has all of this mapped into memory, and it's just updating that kind of live. So what we see here, I mean, we have the Snabb process running, and like the latency histogram, we could hex dump that, for example, and what we're seeing there is the live state of that application running right now. And if we run that again, we get the live state again. So this is kind of real-time, raw access to memory that the Snabb process is updating with information about what is going on. And this is interesting for a few reasons. One is that we can grab this data at any time. So while the process is running, we can passively pull all this data off the file system without interacting with the process in any way. So we can snapshot this as often as we want, and archive it, and the process won't even know that we've done it because we're just accessing this in shared memory, which is really nice, because the last thing you want is for your kind of diagnostic tools to have an impact on the servers you're providing. Then you would have to be very cautious how you use them. So here we can just snapshot the state of a process at any time, and also if we would get a crash, something horrible would happen, we get a seg fault or anything happens, and the process dies, this will be still there in the state that it was, up to the bitter end. So this is very nice in that sense as well. You always have this data, even you have this data even before the process is terminated, and even after the process is terminated. You always have this, and it's kind of free to update. So this is the basic model that we have for Snabb. It just makes its internal state available, and then it depends on tools being clever enough to decode this. And we've written a lot of tools that can do that, that can decode this in interesting ways. And now with this Studio GUI, the new thing that we have is a kind of a unified front end for stitching all of these things together. So we have lots of different utilities that can decode, like the latency histogram, or can decode the profiling data, or can decode the audit log and everything. And now what we're doing is kind of assembling them all in one place, so that they're all at our fingertips all the time. So I have previously updated the continuous integration server to grab that data when jobs finish. This is not on our main line yet, because a lot of this data is specifically generated by RaptorJIT, and the RaptorJIT support in Snabb is experimental. I just submitted it, I think, 2 days ago for mainline. So this is something we're about to kind of migrate from LuaJIT to RaptorJIT and suddenly have all of this data available in Snabb. Meanwhile, I have a one CI job where I've just done that. So here is a CI job for Snabb. We can see what it kicks out. So this runs a bunch of tests, and it generates some graphs. It compares the master branch with the RaptorJIT branch, and this is broken down in various ways. It can be broken down by different a lot of different factors. One interesting one, if we have it here, is I ran 2 different configurations. I ran like an iPerf benchmark with just running just a normal TCP traffic, or running TCP traffic with tunnel encapsulation and IPsec as well. Anyway, I ran a couple of configurations here. Not interested in those graphs particularly now, but we also get a CSV file that lists every test that was done and how that performed. I'm not sure if we can get that inline in the browser. It's going to go off to Google Docs. God help us all. Let's hop out of that. Okay, so we can get a CSV file with all of the tests, so we can see individual tests if there was something that looked interesting or anomalous or anything like that. And then on the CI, we can also address each and every test that was run. So if we take one, let's take one that has IPsec, for example, because it'll just possibly have more interesting data. Here's a test that ran RaptorJIT with IPsec. So here we can get a bunch of log files. We also get this tarball, and what the tarball contains is all of those files that we were just poking at in the shell. So after the process has terminated, in this file we have the audit log, we have the profiler data, we have the final values of the counters, we have the latency histogram and everything. So after a test is run on CI, we can then grab this file and inspect it. So that's what we want to do now. So if I copy that address, what we want to be able to do is to write snabb.inspect and then give it a tarball. And what we want to happen is that we click this kind of go button, and we get an inspection to see what was happening in that Snabb process, and we can click our way through the profiler data and everything. And at the moment, I'm focused on this on the RaptorJIT data. So what's going to come later is decoding the counters and decoding the latency histogram and these other kind of specialized things. What's going to come first is the stuff that we see here, where we just get the data from the RaptorJIT VM, which is 2 things: the audit log containing all the generated code, and the profiler data that kind of helps us find the needles in the haystack to navigate the generated code in a meaningful way without getting bogged down in irrelevancy. So if I would click this, what will happen is it will it will run some Nix code, which will be backend Snabb default.nix. It will run some code here. So this is the Snabb API for Nix, and I don't have any function there called inspect. So if we ran that, we would get a Nix error saying that we didn't have that. But do we have something similar? Process tarball with the URL, fetch the URL and process it as a directory. So actually, maybe this is something that already does what we want. I don't have this swapped in at the moment. I don't. Just glancing, if we ask it to process a directory on disk, it'll check that there's an audit log there, and otherwise it will error. So that's a basic sanity check to see if we gave it a reasonable directory, if it really is a Snabb process. It will copy the directory. It's doing some pre-processing here. So it's going to copy the directory from its source location into the place where the GUI is going to see it. It's going to not preserve the permissions. And it's also going to do this other thing, which is to copy in some dwarf debug information. So this is a little bit of a workaround actually. So the GUI, to decode the audit log, the GUI needs to understand the exact layout of all the internal C structs in the virtual machine, and it gets that from dwarf information. And what I should do is actually include the dwarf data in the log, so that we always have the up-to-date one. That's not there at the moment, so it needs to be provided separately. And in this case, we just have here in this directory, we just have a JSON representation of the dwarf debug information that we're just copying in. So that needs to be maintained manually at the moment, and it might actually not even be up to date at the moment. So one thing that we need to do is make sure that we have the right contents there. And then this is renaming or symlinking something from engine VM profile to just VM profile. I don't think that that's needed anymore, though. I don't think that we need that. Okay, there is some chance that if I would replace inspect with process tarball, then this code will run and do what we want. I'm going to give that a 25% chance. Process tarball, is that what it was called? Yes. What happens when we press this? Click, run. So now what Nix should be doing is going off, downloading that from the CI. We got an error. And this might be something with stale dwarf information. So we got an error while doing some kind of dwarf debugging. I think, in the name at least of caution, I think we should update that that dwarf information to in case it's out of date. Okay, let's see how we do that. So this is a little bit awkward, right? So at the moment, on the one hand we have data that was produced by the CI, and on the other hand we have this dwarf debug information that comes from a completely other source that has to be perfectly matched, and I'm not sure if it is at the moment, and I don't want to dive into this bug without knowing in advance that this is up to date. So let's update that. And we will do that via our Nix API. Let's look when we have code already for RaptorJIT. And what do we do? When we inspect a RaptorJIT process, so when we build RaptorJIT, bear with me. When we're running RaptorJIT, when the GUI is driving all of the execution, when it actually runs the RaptorJIT process, then when it installs, it grabs the debugger information and saves it in this RaptorJIT.two, and then later it uses a little utility of ours to convert it from ELF to JSON format. So that's all automated when we're actually running the RaptorJIT VM from the GUI. But in this case, we're not doing that. We already ran it separately on the continuous integration server, and now we need to match this up. So I think what we need to do is do this generation step directly instead. Okay, so let's look at our dwarfish. Backend dwarfish. So we have a little Nix library that takes an ELF file for input, and it can turn the ELF into text, YAML, or JSON. And JSON is what we want in this case. So first we need to get the dwarf file, and the easiest way to do that might just be to build our RaptorJIT. So let's hop into our Snabb directory and see if we already have that. Here is a Snabb on my RaptorJIT for upstreaming branch. On the right branch, we'll build to make sure that that's all up to date. And if we look in okay, this that is from our current up to date, the version of RaptorJIT that we want to be the version of RaptorJIT that the CI is running. This is the dwarf debug info in ELF format. So what we want to do now is convert that into JSON and import that to refresh what we already have, and then we know it's up to date, and then we can see if we still have that data import problem or not. So let's just do that. We will Nix build. We want to say dwarfish.elf to JSON. We want to give it this path. And that's not going to work because it's not going to find the dwarfish library. So we need to import that. So we're going to say with import what did we call our directory here? Video installer. Oh, that was too easy. We have our okay. We have our result. The result of the build is this file here, and I think we will find that this is a JSON representation of the dwarf debug info. Yes, it is. And now what we want to do is just refresh things a little bit. We'll copy that file into that, and then we'll diff that to see if there was actually any difference. No, okay. So actually that was already up to date. So that was worthwhile as a. Wait, hang on, no. There was a very, very minor difference that may be significant. Something moved. Very, very slightly. Okay, so let's try running again now. See if we still have the same error. And when it runs this, it's actually going to go off and pick up the latest version of the file system. So it's something that I like, that if we edit those Nix expressions on disk and click here, then it uses the current version in the directory. So will it work, or will it have the same error again? Let us see. Has the same error again. Okay. So I guess we need to debug this. So we are into our debugger. We're in our inspector. We're running the go method, which is what happened when we clicked this little green button. And it's trying to load. Actually, it's a bit interesting here. We're seeing another problem that I wasn't conscious of before. So, I mean, now we're in the Smalltalk debugger here, and it's actually a bit mangled. what we're seeing here. See, that's not highlighting the right thing, so it's not actually picking up the right sources. So something in the way that we're running, this this GUI is missing the sources that are up to date. So we got two problems. One is it's highlighting nonsensically here. So obviously the runtime information about what code we're running is not matched with the source it's got here. The other thing is these look very much like automatically generated names. So I think that the code we're reading here actually has been decompiled because the source was not available, and the decompiler has just assigned these names randomly. So actually in the past I've been very confused by this, trying to read Smalltalk code and wondering why people don't use any comments and use such funny names for all of their local variables, and then you find out that it's actually because the tool is not finding the debug information. You're actually reading decompiled code and not source code. So I'm not going to fall for that again now. We're going to stop and fix that. We are going to look for why that can be happening. Let's look at the way that we run things and see what's lacking. What happens when we run this Studio VNC script? Something will be lacking. So live coding, right? You set out to do one thing and you end up having to do something completely different to get there. That's just life. We're just going to fix this. We want to go now into very funnily named backend front end. The Nix backend is what builds the graphical front end, so we get that amusing file naming. Studio VNC, and it's going to be Studio. It's going to call out Studio X11, the script. What does that do? This is how it runs. So when we run it, it copies some things into the current directory, which is actually a little bit suspicious. I don't see it should be a problem here. This is also something that might require a bit of sandboxing. If our script is actually copying the image file into the current directory, it might be surprising to the user. It might overwrite something else. But then why would that? The problem might actually be that I've been hopping around and I started the GUI. That'd be the problem. Whether I started the GUI from a different branch. It doesn't seem like that should actually be an issue, although I might restart it to be sure. I think that if we have the image file and the changes file and they match, that we shouldn't be seeing this error. Let's wait to that. Let's try restarting it just to keep our feet on the ground here. In case there's something kind of dirty about this. Let's copy paste the little script. Safety of an Emacs buffer. And then let us another instance of the GUI. Should be perfectly up to date. Let's see if we have the same issue there. I'm guessing that we will, but it's nice to sanity check these things. Before we spend so much time. I don't think I'll get the host name. Here's a fresh here. We're copying our script. Press run, and we expect to see the same error now. Let's see. We have the same error, so now does the debug information look sane or not? Is the relevant question. Yeah, that looks better, actually. Now we're seeing reasonable names for temporary variables and the highlights. So I'm not completely sure what fell out of sync there. I think, yeah, I have a pretty good idea actually. I think that when we start the GUI, it copies this this image and changes file that need to be perfectly synchronized. It copies them into the current directory, and then if I run the GUI again, it's going to do that copy again. It's going to overwrite them. So those files on disk are only really going to match. They're only going to be a match for the latest version, for the most recently run one. So if I run the GUI and then I run the GUI again, and the different versions, then the new one's going to have all the right data, and the older one is going to have the wrong ones. So we're going to have to fix that somehow. We'll come back to that, and I think there'll be a simple fix. We'll just with Nix, we already have the SHA-256 of these files and that kind of thing. So I think we just got to give them distinct names and maybe even put them in a separate location so that we don't bump into that problem. Anyway, for now we have a working debugger, so we should be able to figure out what's wrong. From the top, we press the Go button. It's trying to do a Nix build, which succeeded, and now it's trying to initialize a RaptorJIT process object from the output of that build. This is trying to load the audit log from a particular path with dwarf debug information that we've loaded from a JSON file. So it's already loaded the dwarf information successfully in there, and now it's trying to load the audit log. Keep going in. The audit log is in message pack format. The kind of outer envelope is in message pack format. We have a message pack decoder, and we are looping through that, adding records. And at a certain point, we try to add a record, and it doesn't work. Try to add a record from a dictionary, and the dictionary we're getting 0 when we expected presumably a dictionary. So I think the message I think the message pack file has an error, and it might well be, it might well be that when we ran this test we did like a kill -9 or something at the end on the Snabb process. So it's possible that the end of the log is kind of invalid. It might be that that even we need another flush in the VM runtime system somewhere to try and minimize the chance that an abnormal termination would be problematic. But I think what we could try to do now is put a little bit of error handling here, because it can always happen that this process crashes or is killed or whatever at an inconvenient time when it's in the middle of writing a record. So this code should be made a little bit more robust actually. And then I guess there are a couple of classes of error, right? It could be that it actually fails to decode the message pack because the message pack data is invalid, or in this case, it seems like something has happened such that it manages to decode the recorded message pack, but it gets a 0 where a dictionary was expected. So it's where it successfully decodes, but it didn't work. Let's just do this a little bit piecemeal for a moment. We'll grab the message and we'll say there's such a thing as is dictionary. That's what we want to know. We will say next dictionary if false, then we're out. And otherwise, we pull it as a record. So this is not perfect, but it might be kind of decent actually. So if we do a read from the message pack file and what we get is not a dictionary, and something is wrong, we're just gonna finish. We're gonna assume that the rest of the log is garbage and just try and make do with what we already have. We'll see if there's enough in there to still be interesting and whether this code works. So now I think we'll restart from this point. now we had a different error. Okay, I was looking for /VM profile. Why did it want that? And we go up a little bit here. We're trying to load the profiler data now. And to keep our feet on the ground, let us look in the contents here. The Smalltalk debugger is kind of neat, right? So here I have a variable that's assigned to a directory. I click on that and it shows me the actual contents of that directory. Because the debugger, it recognizes, I mean, I can see it as a Smalltalk object and see its instance variables, like in the raw view, the kind of like the GDB style view you would get. But the debugger can also offer a little bit higher level things, like to show me the actual contents of the directory. So anytime you have an object in the debugger, you can view it kind of according to its semantics. And this is exactly the user interface that we're piggybacking on with Studio. So this is a really cool interface from the University of Bern and object profile, and I don't know the whole history of who to credit for it, but it's a fantastic thing known as Moldable Tools and the Glamorous Toolkit. Fantastic. This is what we're piggybacking on. Anyway, now let's just get back to it. We do have a folder called VM profile. In there we have a bunch of files, one of which is actually called VM profile and seems to be invalid. Okay, so this turns out to be a good test case, right? We seem to have a file that is not a VM profile, so we probably need a little bit of error handling here as well. So we're getting a cannot open file exception. I've got a feeling that might be a symlink or something actually, but in any case, if we fail to open one of these, I think we'd just like to skip it, right? I'm not sure how we should really do logging in the GUI, but I think what we want to do, for right now at least, is just to skip any files that are not valid. So why don't we do that? Why don't we, in here, when we load one of these, we'll wrap that in a block, and we will say and not a Smalltalk guru. Let's see, how do you suppress an exception? So Smalltalk exception handling. The best would be actually if there's something that suppresses the error and logs something. That would be really neat. Let's see. Local tools is not what we want. Exception handlers. So that's if we wanted to actually take some specific action. That would probably do the job, but is there some pre-cooked thing to do? An exception. Is there any pre-baked log and ignore? Oops. I don't think I want to have Slack open while I'm live coding. Retrying, resuming an exception, there's a lot of stuff. Passing exceptions on, resending exceptions can give us. I think they're getting more complex rather than simpler. Okay, so let's go back up. The on-do, that's what we're going to use. We're going to run that code. Where do we have our GUI? It was here. Oh, no, sorry. I have a few GUIs open. We're going to say on error do nothing. Sounds about right, doesn't it? So we would like, we can put a comment here, flash user visible warning. We'd like a little, a little message thing to pop up saying we skipped something, without requiring any action, just to make it visible. So let's try that for now. And let's go back and run the whole thing again from here. see what happens. So what we're hoping now is that it will see that the audit log was not completely valid, but it won't worry about that particularly. And it will see that one of the VM profiler data was not valid. It won't care about that particularly. So I ran this, and nothing popped up. And I think what that means is that it returned nil somewhere. So if you run something and it works, but nothing pops up, it means it didn't yield any results. So now we need to look again at a similar bit of code. So look again at Studio Inspector. We're going to find again the code that we had in the debugger. It was this Go. So presumably, we did the Nix build, and we tried to create a RaptorJIT process. Nothing. We didn't get anything back. So, did we express the error in the wrong way somewhere? From path, here's where we were. I mean, I don't see that would particularly have been a problem, because this is not actually bailing out anywhere. It's just locally suppressing that error there. This may not be where the issue is. What if we try it on a simpler example, something that already works? If we run RaptorJIT.run, that work? No, oh, okay. But that's encouraging in some sense. It's not something in our new code particularly, I don't think. It's something a bit more broken. Hang on. Let's open a new one of these windows, just out of superstition. And let's run here. Just out of curiosity, was it that particular window that was stuck? Yes, it was. Okay. So sometimes when I'm popping in the debugger a lot and restarting things on the stack and that kind of thing, sometimes I do actually screw up one of these windows such that the button doesn't work anymore. And I'd like to come up with a reproducible test case for that I could share with these clever people at the local university in Bern, which is not far from where I'm sitting now. But for now, I'm just gonna carry on. Because maybe we're getting close now, right? Maybe this could work. What's going to happen? So now we're going to try and load the Snabb data again from this process that actually ran on our CI. And holy smokes, it actually came in. This is cool. So now we went out to our continuous integration server. We downloaded a snapshot of the data from a process that had been rudely abnormally terminated. And we're able to do a little bit of a post-mortem on that now. So here we've got profiles for different components of the system. So for a bridge application, for IPv6 handling application, for the IPsec code, for some VLAN tag on tag, for the tunnel encapsulation, and for the vhost, which is sending data to and from a virtual machine. It's really cool that we have this. And the first thing we can see is how many profiler samples we got everywhere. So we can see that the most time was spent, as far as the sampling profiler is concerned, in the IPsec code, which makes sense because we're doing encryption on the CPU, and that's pretty expensive. So there were 6,000 samples taken there. We get roughly a sample per millisecond, so it's about 6 seconds worth of time. But it's the ratio that's most interesting. And then the virtual machine communication was the next most expensive thing. And we can also see here that within the IPsec code, for example, we spent around 97% of our time in machine code and a little bit of time in virtual machine code, and actually also interesting is we had a 0.1% garbage collection there, which actually is something I would like to eliminate normally. Normally we want 0% garbage collection everywhere, so normally if you see even 0.1%, that's considered a bug. But this is cool data. This is interesting. This is interesting and probably actionable. Let's poke a little bit more. If we select the IPsec, we got an error. Before we fix that, let's click on another one just to see if we can cheat. Okay, so I have a bug. Let's fix this. Sorry, let's fix this right now. Click on, we get this error. This is audit log. Traces was sent to nil. So process audit log is presumably returning nil. Is that right? Yes. If we browse the process, why don't have the audit log initialized? I wonder if this was related. I wouldn't think so. I wonder though if this is related somehow to the thing that we did for dealing with corrupted audit logs. If we look at the Smalltalk object, yes, there's a variable called audit log which is nil. So in other words, we did actually decode the audit log from disk, but it didn't somehow get referenced in the Smalltalk object that represents a RaptorJIT process. So let's fix that. Probably related to the fix that we made for dealing with an audit log that that has a bad format that ends with the problem. So then that was in here. RaptorJIT audit log. We have our object that represents an audit log. It has a method somewhere called load from file named something. It's not a problem. Okay. So that's going to return nil. So there was no return here anywhere. So I thought like a Lua programmer and return nil, thinking, if when nothing happens, it will return nil, of course. But that's not true. In Smalltalk, if you don't have an explicit return, then you return yourself. So if we just want to bail out here, then we should return ourselves. We shouldn't return nil. Fine. Let's run it again. I think it has run. Okay, so it has run, but it's not working. So I think the thing is we noticed that our audit log was corrupted. It might be it was too corrupted. Yeah, it seems like we didn't really get anything out of it. Actually, I think we didn't get anything useful out of our audit logs. I think our whole audit log didn't work. So the data that I'm trying to process is invalid. We saw all of this because you might recall that on disk we have all of the JIT code here in this audit log file, which in our case I think is trash. And then separately we have the profiler data in this other folder with all the profiler data sets. We had one that was invalid, the other ones were valid. So the symptom that we saw over here is that when we look at the profiler data, we get a really nice, we get all of the information. We can see all of our profiler data sets. We can see how much time we spent in each one. We can see within that data set the ratio of time spent in different states, a machine code versus the bytecode interpreter and runtime system versus the garbage collector. But when we try and click this to get it cross-referenced with the actual code that was generated by the JIT, then we see nothing, and that will be because because the contents of that file was wrong. So I'm going to need to fix the CI to somehow produce valid data, and it might be that what I really need to do is update the RaptorJIT VM to flush the log at better times or something like that. Anyway, we're going to take that separately. For now, we'll just generate locally on disk a bit of data and operate that way. So let's, before we run a Snabb process manually, let's just do that again. we will just run. I'm running with some special environment variables to ensure that the files survive the process termination. The default behavior, I'll run it for a little bit longer too. The default behavior with Snabb is that when the process terminates, you remove the shared memory files. So if you want to keep them for diagnostic purposes, then you need to set a couple of flags, which is what I've done here. So it's going to write into /temp/shm shared memory. So we'll let that terminate gracefully, which it has done, and now we should have some data there. So why don't we now write? I think we had snabb.process directory. Oops. And what was that PID again? 21359. Let's try that. So this is not going to be as interesting data, yeah, because it's wasn't as interesting of an application, but we'll see if it works. No, it doesn't work. That is both good news and bad news. Bad news in that we don't have a punchy demo right now. Good news in that maybe we fix a bug in the UI and we can actually use the data. Maybe the problem isn't the data. Maybe the problem is the code in Studio here. So let's have a look at this, because I would be surprised if there was anything really wrong there. So did we get any events? No, we got no events whatsoever. We go in at the Smalltalk level and open our audit log. What do we have? We have 0 events. We have a dwarf data. We don't have any events. So somehow when we decode the audit log, we didn't get any events. Let's find out why. Pull up the audit log. In this little, I'm using a little kind of a search function here that is very general. We pull up our audit log, load from a file. This is some code that we modified. Also, one thing is, if we would ever get something here that's not a dictionary, we're just going to bail out. So is this misfiring? Is there something happening at the beginning of the file? Maybe we want to set a breakpoint here. Maybe we want to say, give us a breakpoint so we can see what's going on and then bail out. Let's see what happens there. There's our breakpoint. So we got something that's not a dictionary. What was it? It's a 0. I mean, it kind of seems like this is happening early on. We have a collection, a vector of events we're trying to populate. What we want to do is decode the message pack record into next. Check that it's a directory, and we were expecting this to always be true, but it's not. And then we would call an add record method to take a dictionary and populate a real event. Here we are. I guess events. There are no items in events, so this is the first thing we get. Interesting. This is the first thing that we get out of the log. So, just in the interest of taking a step forward and seeing what's going on a bit better, why don't we do this a little bit differently? Why don't we just skip any entry? It's not a dictionary. See what happens. So we check if it's a dictionary, and if true, then we will add it as a record. So we're just going to quietly ignore now any records that are not dictionaries. Okay. Let us rerun that. Invalid UTF-8 detectors, and now we try to decode a string. Okay. So it kind of seems like our audit log file is really messed up. This is kind of my loose impression here. But maybe we'll take a look at that message pack file. I think that our message pack file is kind of hosed, and I'm not sure why that is. And it's both on the CI, which I think might have terminated the process abruptly, but it's also from our local run that we did, which actually let the process run to completion. And also it seems like the corruption we're seeing is at the beginning of the log, which is not really where you would expect to see a problem, due to an abnormal shutdown or something like that. So it's probably something a little bit more fundamental that's wrong. So let's have a little dig. We'll use this lovely message factor JSON utility. Have a poke around. Okay, this is the directory that we were just poking in now. And if I look in my shell history, I have suitable arguments to message factor JSON. Okay. Wow, okay. There's a lot of funny nonsense at the beginning. A lot of funny nonsense at the beginning. A lot. But at the end, it was actually looking good. So this, I just scrolled down to the very end. That looks like the right information. So we do have a lot of stuff. But at the beginning, we had a lot of garbage. So garbage at the beginning and good data at the end. If we keep scrolling up until we find the boundary between garbage and real data. What's the first thing that gets logged? So the first thing that gets logged is some machine code memory. So I happen to know that the first entry in the log should not be this. So we've definitely missed something. So somehow the beginning of the log has been garbled, and the beginning of the log has been garbled, and we missed something that we need. So, and this happened even in the simple case where we ran the VM ourselves. So I think that this is a bug in the RaptorJIT VM where it generates the audit log. So this is where we blame the people who supplied our VM, but unfortunately we're in the VM business ourselves nowadays, so actually this is our own fault. So let's fix it. So where is that code? And actually I have a kind of a feeling for what might be involved here. So there is actually some special handling for the first part of the audit log. I can maybe illustrate this in the code. The thing about the audit log is we want to have really complete logging of every decision that the JIT has made. So we want to be logging from the very moment that the runtime system starts. But at that point, we don't necessarily know where the log should be written. So in the case of Snabb, we specifically want to get up and running, create our RAM disk folder for diagnostic information, and then put the log there. But that code is all written in Lua, so the VM is already running. So the question is, what do we do when the VM is running and producing important information, but we don't know where to log it yet? And my solution is to buffer it in memory up to a maximum of 1 megabyte, and then flush that when a file becomes available. And the stupidest thing I've done so far in the last recent history is to use POSIX files. I can't believe how many problems I've had just using POSIX files, and I kind of, I kind of hate POSIX, so I kind of assumed that I would have I would make some stupid mistakes. But some of these problems, dealing with things like writing into a memory file and doing read and write and doing seeks and stuff, some of these things, when I Googled them, turned out to be due to bugs in really, really, really recent versions of glibc, well, at least in one instance. So to me, the idea that POSIX files, like fopen and fwrite and this kind of thing, to think that like there's serious bugs that prevent things like seek from working properly in simple usages in like 2016, 2017 kind of era, that's mind-blowing. So it kind of it validates my strategy 99.9% of the time to stay the hell away from glibc and that kind of thing, and just do everything a little bit more directly. And then I was obviously an idiot in this very unusual 0.1% case where I decided to just outsource this work to glibc. Anyway, dependencies suck. We already knew that. It's nice to remind ourselves sometimes. So this, anyway, this gives us an excuse to open the audit log file. And also, having said all that, I'm sure we're now going to trace this back to something really stupid that I've done, and I look like an idiot, but that's also part of the fun of live coding, of course. I'm quite comfortable with that. So anytime, this will be a bit of a slapstick setup, I guess. Anytime I blame other people for something, it's surely inevitably going to lead to me having done something really dumb. So let's find that dumb thing that I've done. So we're generating message pack, and we're not using any kind of a message pack library because, as we said, dependencies suck. We're just actually writing the raw message pack data out to disk with you know, a character and string at a time, because message pack is a really nice simple format, and to write message pack logs just with raw C code is really easy. So I mean, we're talking like 50 lines of code or something for our message pack implementation, which is fine. Well within the threshold that we don't need to go and bring in another library. But is something funny happening when we open the log on disk and need to get our buffer, flush our buffer there? So again, our log is total garbage for the first part. I'm just going to pull it up again briefly. I realize we already have this fresh in our heads, but nevertheless. This is the beginning of our log. This is total garbage. This is not what we want. If we seek to the end, then this is great. This is exactly what we want. So at some point in the middle, our log has gone from transition from being garbage to being good stuff. The question is, why did that transition? And the first place we're going to look is in the code that opens the log, because we have this thing where the first events get buffered in memory and then flushed to the log on disk once it opens. So that is a place in the code where the first part of the log is treated differently from the later part of the log. So it's very likely that it's some problem there. And as I say, I've had some problems there before using things like fmem open, which I kind of assumed that all the bugs would have been shaken out of 20 years ago, but that was very naive of me. So what do we do? Let's look at the very first event that gets logged, shall we? So at some point the JIT is going to wake up, and for example, it's going to log a bytecode, and it's going to call the runtime system is going to call this logging function LJ audit log new prototype to say, hey, I defined a new bytecode function. Please log this for later analysis. This is going to call ensure log open. What's that going to do? That is going to check if we already have a file pointer initialized. If yes, then we say it's fine. Otherwise, we check if we've already detected an error, in which case we say no good. And otherwise, if this is the first call, then we are going to open a log in memory with the fmem open library call. We're going to give it a maximum size, and we're going to tell it we want read-write binary. And then we're going to do this. As soon as we open the log, we log these VM definitions. So there is some data that's not in the dwarf debug information that we need to log there, here instead. So that means that predictably the first log message in the log will be LJ IR mode, and that's kind of how I knew by eyeball that we were missing some log entries, because that's got to be the first log entry. If we don't have any LJ IR mode, then something went wrong. We're supposed to have one of those messages, and it's supposed to be the first message, because here. So that didn't work. So we're going to assume that something went wrong with this in-memory file. What could it be? We open that file, and then we're going to do some logging. And the logs are going to all write to this FP, which for now is memory. And then at some point, we're going to want to migrate over the disk. Right, so at some point, somebody is going to call LJ audit log open with the path on disk. And at that point, we say, okay, now we actually know where we want the log messages to go. So, we take the ones we have buffered in memory and we write them there. So first, we make sure the memory buffer is already open. Fine, because we want to make sure that we have this initial in-memory log, partly to make sure that we get these. Anyway, so after this runs, we know that we have a log up and running in memory. Then we open a new one on disk, which is read-write You know, once upon a time I was doing some seeks. I don't think we need the pluses here anyway. Isn't the plus that gives you read and write? I think that these are actually kind of write only. Anyway, for now, what have we got? Migrate the contents of the existing log. So we take our memory log and we seek back to the beginning. This has vaguely the look of code that I've already had problems with and already rewritten, you know. I wonder if in my RaptorJIT repository I have a topic branch that looks different to this. Let me check. Because, as I say, I had some problems with libc functions not doing quite what I expected, and it was kind of related to these things like when you have a file that you're both reading and writing and you do seeks, and at least one of those bugs actually was a glibc bug. So I've got a feeling that I need to merge another version of this over from somewhere else. So we hop over into my RaptorJIT directory. What have I been up to lately? If I go to my audit log branch, there I am. If we look here, is the code the same? Okay, so this is a different version. Okay, so I had already written that code. And I think that what I did was I switched to this open mem stream from whatever the other one was. So basically I used a different version where I supply the memory. Oh, no, not quite. Anyway, I just switched to, I worked around a glibc bug, if I recall correctly, by just using a different way to log into memory. So why do I not have this commit where I want it? Have I pushed this to my upstream, to my GitHub branch? Your branch is ahead of Luco by 5 minutes. Okay, so it looks like I've done some local hacking. And I haven't pushed that to GitHub, although it doesn't seem like... Hold on. What have I not yet pushed? Nothing relevant, so bear with me. I want to get that latest code onto my Snabb branch here. So let's just do that. We're on my branch of Snabb that I'm gonna say I grab that. I'm going to merge that in. Get some conflicts we're unlikely to care about. So this is a little bit interesting, right? With Git, we have a Snabb repository, and we're merging a RaptorJIT repository into this. Possibly should be using subtree things, but the thing is that Git is a little bit magical, right? I think I should be using subtrees, but it kind of works. I merge the RaptorJIT, and Git figures out that that I have all the right files, just with a different path. So actually, I'm going to have to revisit this before we merge it on the Snabb and make sure that my Git workflow here is okay. I think it actually is. But anyway, so we have these. These files are added by us. Okay, fine. Let's just stage those. Place. How do we resolve that? conflict. This is a file that we don't care about at all. Those were removed on the RaptorJIT branch. Why don't we just delete them? Ah, okay, yeah, these other. Those ones are all gone, fine. I'm not using the ideal workflow, but I think it's going to be okay. We're not. This is just my development branch, so if we do something really awful, it's not actually going up to Snabb master or anything. Nobody else is going to get this until we're happy with it. So now we can try building this. So I guess people may be skipping around. Just to clarify, what we've done is we managed to run some Snabb processes. They generated a bunch of diagnostic information. We tried to import that into our nice fancy GUI over here. It didn't come in successfully. It turned out to be because the audit log from the RaptorJIT VM that was generated was totally trashed, and then we tracked that to being a problem that I'd already fixed, but I hadn't brought over to the Snabb version of RaptorJIT, so it was on another branch. We've just pulled that in. Now we're going to run. We're going to run our little Snabb test again to generate new data. I got a seg fault, so maybe this one that I pulled had other problems. Maybe I broke something with that git commit that I just did. Possibly. Okay. Let's do this in a different way then. So I just kind of did a messy job of merging, and I probably should have pulled a subtree, for example, when I didn't. What I'm going to do is just take a step back. Going to make that merge disappear, and we're just going to cherry pick the actual relevant commit. What would that have been? Probably that we needed. Let's take a different approach yet again. Let us say, what's the order of arguments? Let us say git checkout the file I'm just kind of trying to take the direct approach here to grab the fix that we need so that we can test it. That may have done the job. Run that and see if it's any better. So now we've rolled back to the Snabb that we were already testing before that just had the trashed audit log, and we've taken the latest version of specifically the audit log file, and now we're going to see if that gives us what we want. So when we're going to kind of take a step back so we don't have a lot of worry about merge conflicts and poorly done merges and that kind of thing. We'll do that in a cleaner way later. For now, you just want to get the data and get it loaded up. Okay, so we have some data. Here, and if we decode this with message pack, now it looks correct, right? So now what we said was the first log message in the audit log should always be this LJIR mode, and there shouldn't be any garbage there, and now that is true. So what we're going to do then is we're going to try loading this now to the GUI, and we've got to change the PID number 27054. Everyone remember 27054. 27054. We'll run that, and we'll see if we have any more luck. And again, this is a little synthetic benchmark, so the data is not going to be that interesting, but we hope it works. And if this works, then we can try generating some more interesting data. Now our profiles. Last time when we clicked on one of these, we just saw nothing. Now we see what we want. Now we say, zoom in on the engine profile. Okay, we had some JIT code that started on this line of code, and it was compiled into this complex of traces, and the code looked like this. A lot of funky stuff. So anyway, what we have now is data we can look at, which is cool, which is very cool. But what we want to get now is more interesting data to look at. So let's now push this code to CI and get a run from there. And that's pretty easy to do. So I have a branch called optimize on my private repository. The CI is watching, and anytime I push any code there, it automatically kicks off a CI run. So if I say git push with force to my repository, and I want to send the head. Hang on, have I committed this? No. Okay, we're just gonna. This is still just a topic branch at this point. We're gonna push it somewhere the CI can see it. Git push with force to my fork. I'll send the head revision, which now includes that commit, to the optimized branch. Now I can go to the CI. I mean, so of course the CI would normally, it runs quite a lot of tests, so it can take a little while, but I think we can shortcut that pretty easily. For now, we'll just kick it and tell it to wake up, have a look at this, and the nice thing here is we don't really need to wait for everything to complete. We only really need to have, get the first build done. So now we wait a moment while Hydra is waking up, pulling all of its Git repositories and seeing if anything has changed, and if so, whether anything in its build cache has been invalidated and needs to rerun. We let it think about that. It didn't want to run anything. Why is that? Or maybe it wasn't my optimized branch that I should push to. What was it? It was RaptorJIT upstream. Okay. I'm just going to change that now. So please go and look at my optimized branch instead. So now we'll wake up again, and this time we'll go to a different branch. So I don't know, this is probably going to take 2 or 3 minutes or something, and which is not really enough time to do anything else that's particularly interesting. So let's, except maybe take I guess we can always take a coffee break. Let's do that. Let's take a 5-minute break. After that, there should be some data on the CI that we can load in and inspect. So away we go, and we come back very soon. Bye-bye. back again. And I was just collecting on the to-do list a couple of the things we said that we'd come back to on the way through here. So we will come back to. But for now, we have go to our CI. Realizing that when I was clicking the CI previously, I might have done it in a window that was not visible. Sorry about that. So what do we got? So our CI has woken up, is working on doing this build. Yeah, 450 tests still to run, but some of them have completed. So we don't really need to wait for everything. We just want to pick one juicy looking one. So here are the ones. Those are the ones that are queued that haven't run yet. Here are the ones that have run. Let's filter those to just the ones that were with the RaptorJIT. And so here, for example, it's running with RaptorJIT, should have all the right data, and it's an interesting configuration with tunneling and IPsec and everything. Let's pull that up. Grab this URL. This is for now at least. This is our interface towards the CI. You go in, you find a build you're interested in, you grab the link address, and then you should be able to pull up your GUI and tell it to process. Bit of a generic name, tarball, and then stick the URL in here. See what happens. Okay, so far so good, but this is what we had last time, right? So we see all the profiler data, and this is juicy. We see, wow, there's a lot of information here about the way that the program ran, which components took the most time, and within those components, what they spent their time on. But do we have any events? Yes, we have events in the log, so maybe it will work when we click on things. So IPsec, what happened in IPsec? Drum roll. We have generated machine code starting on these lines of code. These are the source code lines. IPsec ESP.lua line 14. We had a lot of time spent in code rooted there. There was one root trace and no side traces. It was running 100% machine code. So this was probably actually running assembler code, actually. But it's kind of interesting. We have quite a few different. In this profile, we have code that started quite far away. So it's an interesting thing. Digressing slightly, it's an interesting thing with the tracing just-in-time compiler. You can have code, machine code that starts in one place, and it can go actually very, very, very far through an application if the kind of control flow is predictable. So it's possible that two logically separate parts of the application that are also profiled separately actually have machine code in common, or have a trace in common. I'm not going to worry about that too much now, but we can see. Can we see anything about that? The one that I said is probably calling assembler code. Let's see what that looks like. It takes a little while for the larger functions to generate the visualizations. We probably should put in a little progress meter or something here, or something that pops up and says, "Hey, don't worry, don't give up. I'm working hard on generating the graph." Or maybe we could pre-generate things. I don't know. Now we'll just be a little bit patient. So the cool thing here, the really cool thing here is this is one of the very first times that actual data from an actual Snabb application that is actually interesting to understand and optimize has been loaded into this graphical user interface called Studio. So this has been the kind of image I've had in my mind for like a year or something, half a year, I don't know, of how we should do performance analysis of Snabb applications. Wow, this was such a huge amount of code that you really got to zoom in to see anything. Fascinating. So we got really a huge number of instructions in this trace, which might be as a result of something like loop inlining, unrolling, or something like that. there's a lot of information here. This is going to be completely and utterly fascinating to tease out. So if you have like a significant large application here, this is a network stack that's doing tunneling and encryption and interacting directly with virtual machines via kind of pseudo DMA, all kinds of stuff. We've got a pretty transparent view of the operation. We can see how much time each component consumed, what it was doing, whether it was garbage collecting, whether it was in the virtual machine runtime system, or whether it was running machine code. And then we can zoom in on all of the code that was generated to like an excruciating level of detail. And so this is something that we would want to spend a little bit of time looking at. This is not something I'm just gonna in real time interpret, but we have a lot of information here. It's all indexed. It's all indexed via the profiler, so we're actually clicking through to the most interesting and relevant things, and then we can see, we can get different views. We can see the diagram, we can see the text listing, we can see the bytecode view. We have all of these different views. So this is awesome. So this is the tool that we're going to put in the hands of Snabb hackers basically now. And what it's superseding is the normal way that you would optimize code with RaptorJIT, which is basically you would get like a 500,000 line text file with just kind of that just looks like this. You would get a file looking very similar to that just goes for a very long time, and you would kind of not know even where to start because because generally speaking, the JIT generates like 100-to-1 ratio of like boring code to interesting code. Like you need to know which code is actually relevant to performance to know which things you should look at. So you need to be profiler driven in how you read things. Anyway, I'm blathering. Generally speaking, to take a large or large-ish RaptorJIT program it's taken an annoying amount of time to optimize, mostly just because you don't have the information that you want and you have to work really hard to construct it in your head. If you take a few 100,000 lines of log file and try to use awk, grep and stuff to try and put the whole picture together, it's really hard work. You might spend a day or a week or something, and the hope is that this tool is kind of just automating that, so you can just hop around and see things. So I'm gonna dive into this in depth a little bit later. I'm not going to do it right now. I think for now I'm going to say that I'm a little bit satisfied. We identified a few hiccups along the way for getting Studio up and running. We also made a couple of fixes. We need to make sure that everything is committed and pushed in the right way. I might take that offline. I think we've captured everything. So thank you for following along. Again, the big thing happening right now is that on Monday, a couple of days ago, I proposed RaptorJIT for merge into Snabb. The main consequence of that is that this text-oriented JIT tracing profiling view would be replaced by this graphical one. So I'm trying to get this ready to put this in the hands of Snabb users so that they can play with it the way we are here. And I think it's starting to look really, 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 really promising. So just a little bit more polishing, and we should have something really cool to play with. Thanks for tuning in, and let's continue another time. Bye.